Hello, I'm Dan Bowles, and this is the third video lecture in a series to teach the principles of our physical existence as presented in my book, Are We Just Bubbles? An Alternate View of Existence. In the last two lectures, we discussed the physical existence of space and its unseen expansion, and how time and energy relate to the expansion. In this lecture about gravity, and the following one on inertia, we will see that gravity and inertia are related in that both actions on matter are the results of an imbalance in what I call the space pressure equilibrium, which causes a net force against one side of the object. We assume here in our universe that there are a finite number of space bubbles and that no more are being made. That the bubbles are individual and cannot share their space with another, that each bubble contains a creative source of its own space material, and that the expansion forces within each bubble is equal. We also assume that the entire universe consists solely of space bubbles with no voids between them. Each bubble is trying to forcefully increase its volume against the opposition of its neighboring bubbles, which have an equal and opposite force. It follows that the surface boundaries adjoining the bubbles must have flat sides. This is so because if the forces are equal within the bubbles, then the boundaries can't favor one side with a curved surface. Flat surfaces on the bubbles require that the bubbles must be flat-sided polyhedrons. We know and can see that there are some denser clumps of bubbles that make up visible matter with mass, and that there must be something that causes them to remain compact. About the only thing possible that can control the expansion of the bubbles is their geometric configurations and a surface interface condition that requires solitary congruence between the sides of interconnecting polyhedron bubbles. I will spare you the proof, but of these, only the cube meets all of the criterion for the vacuum space polyhedron. All others, when put together like a 3D puzzle, will have some voids between the sides. Vacuum space bubbles must be cubes, and all of them are expanding at the same rate, so that all of the conditions of congruence, no gaps, etc. are met. Now again, I have used a 2D model in the illustration of ease for understanding. It is like a cross-section of space that has no depth, and we are considering only the x and y directions of space. I have represented the vacuum space cubes here as squares in this two-dimensional drawing. We have two highly simplified representations of compacted space bubbles, M1 and M2, outlined in red. These are objects of matter with a property of mass. Looking at this static diagram, it's easy to forget that vacuum space is actually like a non-compressible expanding fluid, and that in reality this diagram is expanding at the speed of light into the void. But remember that this expansion is invisible to us, and that our distance measurements is based on a quantity of space bubbles that everything is made of, and not the absolute space of the void. Now, in studying this, we see that the rate of flow of new space material within each vacuum space bubble is limited by the surrounding bubbles. I will mention here also that since time and the speed of light are proportional to the expansion rate, we can also say that they are relative to the vacuum space pressure. Gravity and inertia are related in that both actions on matter are caused by an imbalance in this space pressure equilibrium. The forces acting on the objects of matter result from a higher space pressure on one side of it versus the other. In the diagram here, there are 22 compacted bubbles in the same area as 9 vacuum space bubbles, which amounts to a density of about 2.6. The mass of the object then would be proportional to the number 2.6. The vacuum space bubbles surrounding the bits of matter are distorted due to the shared, slower expanding sides of the matter bubbles that they border. Remember that in all cases, adjoining sides of the space bubbles must remain coincident. This distortion and expansion causes a slight reduction in the space pressure around the matter because the affected VS, the vacuum space bubbles, can't expand as fast with one side restricted. This diagram is highly simplified and just shows a few of the represented vacuum space bubbles distorted around the matter. But in reality, this distortion is not limited to just the vacuum space bubbles that are in contact with the matter. The distortion in the vacuum space bubbles passes one to the other in a diminishing way as it moves out radially from the matter that causes it. If one object is isolated in space, the reduced pressure around it is equal. All the pressure around it is equal. This is lower here, higher out here. It's all pushing in equally around the object. If, however, another object is brought into its vicinity, the average space pressure between the two objects along a straight line of distance d will be reduced due to the addition of the two space pressure regions around the objects. This reduction in the space pressure in the shadow region causes a net force acting to push the two objects together. The force is greater out here than it is in here, so it pushes this object this way, the same over here. It's greater out here than it is here, so it pushes the object in together. The closer the objects are to each other, the greater the net force pushing them together, because the average space pressure between them keeps getting lower and lower as you move them closer together. Also, we can see that the reduction in space pressure around the objects is proportional to the density of the objects, which is equivalent to the mass of the objects. We can see that the net force acting on the objects from the vacuum space bubble medium is proportional to the mass of the objects and inversely proportional to the distance between them. What has been observed and empirically formulated by Isaac Newton is that the force on each object is equal to a gravitational constant times the mass of the two objects divided by the distance squared.
This is an apparatus that I have set up to demonstrate how the vacuum space pressure acts on bodies of mass to produce the force of gravity. A blower is used to pressurize a jar through an attached hose. Inside the jar are two ping pong balls that are suspended from the jar lid of flexible hollow tubes. A series of holes have been drilled around the circumference of the balls so that the pressurized air in the jar can flow through them to the inside of the ball. The air then travels up the attached hollow tube to exit the jar through the lid. The air flowing through the holes in the balls create a ring of lower pressure all around the circumference of the balls. When air is allowed to flow into both balls, the space pressure is lower than the space pressure on the opposite sides of the balls due to the addition of the lower space pressure between the two balls. So there is a net force on the opposite sides of the balls that tends to push them together. This is similar to how the vacuum space pressure differential causes the force of gravity on matter with properties of mass. If air is only allowed to flow in one of the balls by blocking the outlet hole on the other, then there will be no net force on either ball since both balls have equal forces around them. This too is similar to removing one of the bodies of mass away from another to remove the effect of gravity.